So, just to wrap things up today, when we're talking about these systems, I said, terminology does matter. And so we've described this leg, in the case of the supply, right, from neutral to point A, as a phase voltage. Right? That is the voltage of one of those supplies measured, independently, if you will, to the neutral point. When we talk about this phase voltage in a Y to Y configuration, the phase voltage is the voltage to voltage connection is the same. So the voltage across the full load is going to be the same as the voltage across this phase. Right? So it's as if, again, if there were a neutral point, the centers would be grounded. Right? So we also consider this to be so we've measured the line current, that's what we just calculated, which is the current flowing through the wire, if you will, to our load. Right? We have a phase voltage, and that's the same as the line to line voltage. And then the other thing we can measure is the line voltage. Now the line voltage is measured by measuring the voltage that you would get out of your supplies if you connected across points A and B. So if you couldn't connect to the neutral, right, if there wasn't actually a wire there, what voltage would you measure? Right? So imagine I just did this as a little loop. Let's just look at the supply. And again, these derivations, they are in the book, so you can go back through them. But if I were just, if I were starting here and I went around the loop, and this is point A, and this is point B, and I just connected these together, and this is what I wanted to measure my voltage across, I would just have, negative VA plus VB, right? And that gives me my voltage across the line, right? Equals 0. So the voltage between, here, let me write this, maybe this is instead of shorting that out, being overly confusing. Think about it this way, right? So if this is my point, and I look at this as my ground almost, and the other end of my multimeter is attached here at A, what voltage is it going to read out? Right? Well, it's got to go through both of these power supplies to get there. So it's, in fact, the total voltage is going to be VA and this voltage plus this voltage, VBM. That's the full separation in the voltages, right? So, again, I'm writing this in KPL, right? This equals VAB. Right. So, if I were doing a loop, right, the whole thing, it would be, like negative VAN plus VAB plus VB equals 0, plus VBN equals 0. If I were going around a full loop, right? And so then the minus signs, right, I move everything over to the other side. Anyways, again, it's simple if you just look at this as this is a common point. Obviously, the voltage here has to be, VBN down, and this is VBN up. So the difference between them, which is VAB, is the full separation. But they're out of phase with each other, and that's where the tricky part comes. So you would look at this as, say, this is 120 with a phase of 0, and this is 120 with a phase of 120 degrees. What is VAB?
0?
No, it's not. Because I have to go through this and put each one into Cartesian coordinates. add them together, and then go back to polar form, right? And it actually ends up being, they have it all worked out, like I said, in the book, on page 510, if you want to look at it exactly. But it ends up being that whatever this phase voltage is, just the magnitude of this, that's VP, it ends up that VAB equals root 3 VP with a phase angle of 30 degrees. Well, yeah, except that then the other ones end up being 120 degrees out of phase with this, but all with a magnitude of root 3 VP. And the one reason I wanted to point this out was just that oftentimes we understand like our phase voltage, the voltage on a single phase coming out is like 120 volts. If you deal with three phase, so that's the 120 volts right there, the single phase. But when you deal with three phase, oftentimes it's quoted as 208. And you're like, well, how do you get 208 volts? It's 208 three phase, right? 208 volts three phase, and that is because root 3 times 120 is 208. And so most three phase systems in a standard like environment like this, they'll be quoted out as a 208 three phase system. So you'll see that regularly. And it comes from this, that the supplies are connected in a Y, but we typically measure between two of the lines. So we measure the line voltage, not the phase voltage. Again, this is one of these terminology things that gets the three phase a little bit confusing, right?
Do it, page number for that.
510. So definitely look through that little derivation. It's very straightforward, right? It's just this, and then they just show the calculation steps. Again, it's just combining these in Cartesian and substituting the phase voltage as the magnitude. All right? So we'll start with that again.